Question 6. Two fair dice with faces numbered 1, 2, 3, 4, 5, and 6 were thrown together. Find the probability. Find the probability of obtaining a sum of 7 or 11. So when a question like this is given to you, you have to first of all get your sample space. Sample space, which is the same as the possible likely outcome. When we are dealing with dice, with a sample space, we are going to draw a table to represent our answer. So there should be a table here. All right. Now, because we are dealing with two dice, then we are going to write here die A or die B. So here we are putting the numbers 1, 2, 3, 4, 5, 6. Then with the next die, we have 1, 2, 3, 4, 5, 6. Now this is how we are going to fill the tables. We could see 1, 2, 3, 4, 5, 6 here. We are going to repeat the same here with a comma. So we have here to be 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma. Then let's check the number on top here. The number on top here is 1. So the 1 will run through. 1, 1, 1, 1, 1, 1. You are done with the first column. Very simple. Then here we still have 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma. Then we are going to take the number here, which is 2. So the 2 will run through. So we have 2, 2, 2, 2, 2, 2. Shall we? All right. Here we still have 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma. What number do we have on top? It is 3. So the 3 will run through. So we have 3, 3, 3, 3, 3, 3. Very good. The next column. 1, 2, 3, 4, 5, then 6. And what number do we have on top here? 4. So the 4 runs through. 4, 4, 4, 4, 4, 4. Very, very simple. The next one. 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma. What number we have on top? 5. 5, 5, 5, 5, 5, 5. So now we are at the last column. 1, 2, 3, 4, 5, 6, comma. So 6, 6, 6, 6, 6, 6. And this will be your sample space when you are dealing with the table. The question said we should find sum of 7. So 1 and 6, when you add, we are getting 7. So I'll pick this. 2 and 5, we are getting 7. 3, 4, when you add, we are getting 7. 4 and 3, when you add, we are getting 7. 5 and 2, when you add, you are getting 7. 6 and 1, when you add, you are getting 7. Or 11. So you have to add 11 to it. So from here, 5 and 6, when you add, we are getting 11. Then we have 6 and 5, when you add, we are getting 11. So when you put all of them together, we are getting 1, 2, 3, 4, 5, 6, 7, 8. So we are getting 8 of them all over the total sample space. And there are 36. So we have 36 from here. That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 by 6, we have 36. Now from here, 4 goes here 2 times, then 4 goes here 9 times. Because 4 times 2, we have 8. 4 times 9, we have 36. So the final answer becomes 2 over 9 to be the probability of obtaining the sum of 7 or 9. So therefore, the probability of obtaining a sum of 7 or 11 is 2 over 9. And this is the end of question 6. Let's look at question 7. Question 7. The position vectors of point F and G with respect to a fixed point O are 3i minus 2j and I plus j respectively. Full stop. If P divides Fg in the ratio 5:3, comma, find the position vector of P. And this was question 1A. So now let's deal with that. After that, we look at the question 1B. So here, F is equal to this, J is equal to this, because the question said respectively. So it means that vector OF is equal to 3i minus 2j, comma, and vector OJ is also equal to I plus j. So let me write solution here. All right. And the question is saying that if P divides Fj in the ratio, so now we are looking for position vector P, which is OP. And here it has been divided in the ratio 3 is to 5 is to 3. So here, this 5 will multiply this. So you are going to get 5 multiplying I plus j. So anytime we are dealing with the ratio, it is just like cross multiplication. This will multiply this, then this will multiply this. So the 5 will multiply the I plus j, then the 3 will also multiply the 2i minus 2j. Okay. Plus, then 3 will also multiply 3i minus 2j. All over the sum of the ratios, 5 plus 3. So now we are going to continue with the simplification here. So we have position vector OP is equal to 5 times I. We have 5i plus 5 times j. We have 5j. Then 3 times 3i. We have 9i. Then 3 times negative 2j, we have minus 6j. All over 5 plus 3, we are getting 8. So now we have OP to be equal to, now from here, we are going to group like tens. So we have 5i plus 9i plus 5j minus 6j all over 8. So now let's continue with the simplification. OP is equal to 5i plus 9i, we are getting 14i. 5j minus 6j, we have negative j all over 8. So from here, we are going to split. So we have OP to be equal to 14 over 8i minus, we all know that there is a coefficient of, or the coefficient of j is 1. So it's going to be 1 over 8j. So now we have OP to be equal to, from here, 2 goes here 4, 2 goes here 7. So we are going to get 7 over 4i minus 1 over 8j. And this will be the position vector of P, which is OP. As simple as that. Now let's look at the 7B. B, in a triangle, in a triangle OPQ. OP, vector OP is equal to P, comma, OQ is equal to Q. Full stop. If M is the midpoint of PQ, comma, find in terms of P and Q. I, vector PM. I, vector OM. All right. So now let's look at how we can deal with the question 7b. So the question said triangle OPQ. So now let me sketch a triangle from here. So now I'll make it OPQ, meaning that vector OP will look like this from here, and this is position vector P. Vector OQ, position vector Q. Then we are saying that M is the midpoint of PQ. So the M will be somewhere here. So I have made it dot. But because we'll be looking for OM, I can just join this so that I can get my OM, which can also be position vector M. All right. So now from here, the question said we should find PM like this. PM. Now, PM from here is the same as half of PQ. Half of PQ. So we have to find PM. But before we can get PM, we need to get OM first. So now let's get OM. Then afterwards, we look at the PM. Now, the question said M is the midpoint of PQ. So it means that OM is going to be half PQ. Half PQ. So now we have half of, and here with the PQ, it is going to be OP plus OQ. OP plus OQ. So now it's going to be half of, we know that OP from here, it was P plus OQ is also Q. And this is be my OM. This is my OM. So now we can now deal with the PM. Now, if we are looking for vector PM, then we can going to express this one in position vectors, which is going to be OM minus OP. So from here, OM, we have it here, which is going to be half of P plus Q minus, and we have OP to be P. So from here, we are going to expand by multiplying the half by what we have from the bracket. So we have half P plus half Q minus P. We are moving on. So now we are going to group like terms. We have half p minus the p we have here plus half q. Half minus 1, we are getting negative half p plus half q. And from here, we can just try and then factor the half out. So I have pm to be equal to half here, half here. We can factor half out in a big bracket. It will be left with minus p plus q. And this is the same as half into bracket q minus p. And this will be the final answer for the question 7b. Now we are looking at the last question under the compulsory part. Question 8. A body X of mass 8 kilogram is suspended by two light inextensible strings mx and nx attached to a ceiling. Stop. If the strings are inclined at angles 55 degrees and 65 degrees respectively, to the downward vertical, and find the tensions in each in each of the strings, correct to the nearest whole number. Then the question said, take G, which is the gravity, to be 10 meters per second squared. 10 meters per second squared. All right. So now let's analyze the question step by step. Then look at how it is done. From here, the question said a body of mass 8 kilogram. Then we have the gravity to be 10 meters per second squared. So now mass of the body X is equal to 8 kilogram. Gravity is given as 10 meters per second squared. So we need to get the weight of the body, the weight of the body X. And you know that the weight is calculated as mass times the gravity. So we have the mass to be 8 times 10, and you're getting 80 Newton. So this will be the weight of the body. Now let's start. Let's assume that this is the body and the weight is exerted downward. Then the question said, this body is suspended by two light inextensible strings. So there is one string here, another string here, and the body is X. So it has been held like this, just like, and they have been clipped to a fixed point. That is why he said, and attached to a ceiling. Okay, all right. So if the strings are inclined at angles 55 degrees and 65 degrees respectively to the downward vertical, then it means that the angle here, so let's make here M and I'll make here N. So if MX is the first one, then it means that the 55 degrees will be here, because the question said to the downward vertical. Then the 65 degrees will also be here. All right. Now, from here, I can introduce short dashes up here so that the angle here will be equal to the angle here. So we have 55 degrees here, and this angle is also equal to this angle, 65 degrees. This is equal to this because alternate angles are equal, and 65 because alternate angles are equal. Now we are moving on. Now, this whole angle is 90 degrees. Then if here is 55, then it will let with 35 degrees here. So now 35 plus 90, we have 125 degrees to be the angle here. And again, we know that this side is also 90. If this angle here is 65, then it will let with 25 degrees from here. So now the whole angle here is going to be 25 plus 90 degrees. And we have 115 degrees. Don't forget that the weight is equal to 80 newtons and there are tensions in the strings. I'll name here T1, tension 1, T2 to be the tension 2. So from here, we are going to use the Lame's theorem. Using the sine rule, then it's going to be T1 over, you could see that T1 is moving into the angle 115. So it's going to be over sine 115 degrees because you are using the sine rule. It's equal to, the weight is 80, it's also moving into these two angles if you check. So 55 plus 65, we have 120. So 80 over sine 120 degrees. Then from here, we are going to cross multiply. This will multiply this. This will also multiply this. So T1 times sine 120 we have T1 sine 120 degrees is equal to 80. Also multiplying this, we have 80 sine 115 degrees. So from here, we are going to divide both sides by sine 120. So here we have over sine 120 degrees, here over sine of 120 degrees. This will take up this. So we have T1 to be equal to, so we have 83.7211 newtons because it's a tension. But you know that the question said correct to the nearest whole number. So we have T1 to be 84 newtons into bracket, the nearest whole number, the nearest whole number. The next part, which is the T2, the second tension. So we have T2 over, when you check the T2, it is also entering the 125. So it's going to be over sine 125 degrees is equal to 80 over, you know that this weight is also entering the 120. So over sine 120 degrees. So now we are going to get T2 sine 120 degrees after cross multiplying is equal to 80 sine 125 degrees. So from here we are going to make T2 the subject. So I divide here by sine 120 degrees, here by sine of 120 degrees. This will cancel this. Then we have T2 to be equal to, so we have 75.6700 Newton. And we are still going to correct to the nearest whole number. So we have T2 to be equal to, we could see that the whole number is 75, but the number that follows is more than 5. So we add 1, making 76 Newton into bracket nearest whole. The table shows the distribution of weight into bracket in newtons of 50 chickens in a poultry farm. So we have weight in newtons, 20 to 25, 26 to 32, 33 to 35, 36 to 42. Then we have 43 to 48. Then we have number of chickens. So we have 9 newtons, 8 newtons, 12 newtons, 15 newtons, and 6 newtons. And the question that follows is draw a histogram for the distribution. So my fellow viewers, this was the question 5 under the compulsory part. So now under statistics, when a table is drawn in a question for you, this has been drawn in a row form, you present it in a column form. So we have weight into bracket in newtons, followed by number of chickens All right, so we have 20 to 25. We have 26 to 32. We have 33 to 35. We have 36 to 42. And we have 43 to 48. All right. Then we are going to write their corresponding number of chickens. So we could see that 20 to 25, it is corresponding to 9. So we have 9 here. The next one is 8 newtons, 12 newtons, 15 newtons, 6 newtons. So when you put them together, sigma F will give us 50. 9 plus 8, we have 17, plus 12, we have 29. 29 plus 15, we are going to get 44. Plus 6, we are getting 50, which is the same as the 50 chickens they gave it to us in the preamble. Now, this is histogram. And with histogram, after these two columns, we need to get our class boundaries. Class boundaries. So with the class boundaries, we are going to start from the lower class. So before we can get our lower class boundary, with this we are going to take 0.5 from it. So it's going to be 20 minus 0.5. And we have 19.5. 2, 25. Then we add 0.5 to it. So it is always minus 0.5 from the first class, then 0.5 to the upper class. Now there is something which is very interesting under the class boundaries. Any number ends here will start from here, and it's a trend. So we have 25.5 to, then you just add 0.5 to the 32, making 32.5. So you could see that this 32.5 will also start here. And when you check 33 minus 0.5, we have 32.5 to 35.5. Very simple. Then this same 35.5 will start here. Even when you check 36 minus 0.5, we still have 35.5. So we have 35.5 to 42.5. Then 42.5 will also start from here. So we have 42.5 to 48.5. The next column is going to be the class size. The class size. Now the class size will help us to know how the bars will look like. Because histogram, we are going to raise bars. Bar. So the class size will help us. From the name class size, then it means that the class size, we are going to use the class boundaries to get the class size. So from here, 25.5 minus 19.5, what will we get? What did you get? All right, so we had 6. When you get here, 32.5 minus 25.5, using the calculators, what did you get again? So here we had 7. Then from here, 35.5 minus 32.5, what was your answer? 3. Very good. 3. Then we have 42.5 minus 35.5. What did you get again? All right. So we had 7. Then 48.5 minus 42.5, we are going to get 6. So here it has unequal class size or unequal class width. In that case, then we need to get our frequency density. Frequency density. With the frequency density, it is calculated as the frequency divided by the class size. So from here, 9 divided by 6, we are getting 1.5. 8 divided by 7, what did you get from your calculator? All right, so we have 1.14. We are correcting to 2 decimal places. 12 divided by 3, we are getting 4. From here, 15 dividing 7, we are going to get 2.14. 6 divided by 6, we have 1. And this will be our frequency density. Because the class size are not the same, or we have different class sizes, then we are going to plot the frequency density against the class boundaries for the histogram. So now we are going to continue from here. So let's assume that this is our graph board. So we have our y-axis, then we have the x-axis. Now for every standard graph along the y-axis, we have 12 deep lines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. Then along the x-axis, we have 10 deep lines. So let me straighten the line. All right. So we have 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So we have 0 from here. Now, here will be the frequency density. And we could see that the highest number we have there is 4. In that case, then I'm going to use 0.5. It's going to be 2 centimeters to 0.5 to be my scale. So 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5, 5.0, 5.5, the negative 6.0 to be the scale. And we know that this is the frequency density. Frequency density. And this side will be the class boundaries. And the class boundaries, the first class boundary is going to be 19.5. Now let's look at something from here. Let's pay attention. Over here, we could see that 90.5 minus 0, we are still getting 19.5. But with the other sizes or with the other differences, we are getting 6, 7, 3, 7, 6. It means that here there are certain things that has been cut off. In that case, we need to cut the graph. How do we cut the graph? Let's assume that there is a light line here, there's another light line here. So there is a light line dividing these two deep lines. There is another light line dividing these two deep lines. So you draw a diagonal line to this, a vertical line, another diagonal line. So you draw a diagonal line, a vertical line, another diagonal line to cut. And this is how it is done. Now from here, we are going to count. we are going to do counting. So let's look at how it will be done. This is a deep line. This is another deep line. This is another deep line. Deep, deep, deep line, deep line, deep line, deep line, deep line. In that order. Now let's get how we are going to do the counting so that you understand. Now, between every two deep lines, there is a light line between. You can go and check the graph. There is a light line, very light. The deep to the light line, we have another small line. They are four in number. So we have smaller one, two, three, four. Another one, two, three, four small lines. And again, we have this a deep line, this another deep line, for which we have another light line between. And here there are some small line. There are four. Then another four small lines in between the light and then the deep. When you check these two deep lines, there is another light line like this. Then we have small lines in between. They are also four. And again, this is a deep, another deep. There's a light line, small lines in between. There are four. One, two, three, four. Deep, another deep. There's a light line. We have one, two, three, four. One, two, three, four. This deep, another deep. There is a light line. One, two, three, four. One, two, three, four. This is deep, another deep. There is a light line. One, two, three, four. One, two, three, four. From here we have deep, another deep. There is a light line. We have one, two, three, four. Small line. One, two, three, four. Small lines. So now we are going to look at how we can get the class size. So now let's look at it. Now you could see that with the 19.5 to the 25.5, we are going to count 6. This is how we are going to do the counting. This is 19.5. But let's look at where the 25.5 will be after counting 6. So when I'm counting, I am not going to count this as 1, no. But I'll skip this and this will be my 1. So here I'll be skipping each small line in that order. So I have 1, I'll skip this 2, I'll skip this 3, I'll skip this 4, I'll skip this 5, I'll skip this 6. So this will be my 25.5 like this. So now let me clean the whole of this so that we can get it well. All right, we are going to continue with the counting. You know, from 25.5, we are moving on to 32.5, which is 7. So here, we are going to count 7. So if this is my 25.5, then I will skip this 1, I'll skip this 2, I'll skip this 3, I'll skip this 4, I'll skip this 5, I'll skip this 6, I'll skip this 7. So it's this. So this is where my 35.5 will also be. Then the next one, from 30, that's where my 32.5 rather, 32, so it's rather 32.5 will be. All right. The next one is 32.5 to 35.5. And here the difference is 3. So now we are going to count 3. So I'll skip this 1, I'll skip this 2, I'll skip this 3. So it's going to be this. So this is where my 35.5 will also be 35.5. We are continuing with the counting. The next one is 7. So here I will skip this small line. This will be my 1. I'll skip this 2. I'll skip this 3. I'll skip this 4. I'll skip this 5. I'll skip this 6. I'll skip this 7 because we have 7 over there. So this 1, 2, 3, 4, 5, 6. So this will be my 42.5. Then the last one is 6. That's 42.5 to 48.5. So when I'm counting, I will skip this 1, skip this 2, skip this 3, skip this 4, skip this 5, skip this 6. So it will also be on this, which is 48.5. All right. So from here, we are going to draw the bars. So now we've been able to read each of the lines. So now the one that are not needed, I'm going to shorten them so that we can get the ones needed well. Okay. All right. So now from here, 19.5 to 25.5 from here, 19.5 to 25.5, the frequency density is 1.5, and we can get 1.5 from here. So we are just going to trace vertically like this. Then over here, like this. Let me straighten it. This is how the first bar will be. Then from 25.5 to 32.5, it is also corresponding to 1.14. And we know that 1.14 also lie between 1.0 and 1.5. So let's assume that this is the light line. We have 1, 2, 3, 4, just like the way we read what we have here. 1, 2, 3, 4. And from here, if this is 1.0, I'll skip this. This is 1.1. I'll skip this 1.2. But I am looking for 1.14, which is very close to the 1.15, which is the middle part. So when I'm counting, I'll skip this. I have 1.1, 1.2. So here is where my 1.14 will be. So you just trace. All right. Very good. So this is how the bar will be. The next one, 3, 3. So they are also corresponding to 4 from the frequency. So you could see that the bars has already been drawn. So to 4, so when I trace it to make it very nice, all right, then this is where my 35.5 is. All right, something like this. Very good. So now let me clean this line because I am just trying to trace. Since you are using your graph sheet, you are going to get the lines very well. The next one, 35.5, they are also corresponding to 2.14. And we know that 2.14 also lie between 2.0 and 2.5. So let's assume that this is the light line. We have 1, 2, 3, 4. 1, 2, 3, 4. So when you are counting, we have 2.0 here. I'll skip this. 2.1 will be the next line after skipping the first small line. I'll skip again and I have 2.2. But the 2.14 will also be just around the middle part, which looks like 2.15. All right. So with the bars, we already have them. So we just trace and then we draw. All right. Against this. All right. So this is how it will be. Then the last one, 42.5 to 48.5. Under the frequency density, it is corresponding to 1. And we have 1 from here. This is 1. So, all right. So after drawing your bus, then you just write the name here, class boundaries. Class boundaries. So my fellow viewers, this is how the graph will look like. Very simple. This is how the graph will look like. All right. So we are going to look at the next question. So my viewers, we are going to end here for the WASSCE 2025. In the next video, we are going to continue with the questions. Stay tuned. Bye bye.